This is the first video of Unit 6, Potential Energy and Energy Conservation. In this video, we're going to introduce potential energy and talk about the gravitational potential energy. What is potential energy? Potential energy is defined as a stored energy that depends on the relative position of various parts of a system. If this definition does not make sense, think of it this way. In this picture, you see a man holding a rock above his head. And you know that if the man dropped the rock, work would be done on the rock since the force of gravity is pulling the rock towards the ground from a vertical distance. But before he drops the rock, one could say that there's a potential for work to be done on the rock. This kind of energy is the basis of what potential energy is. There are many different types of potential energy, but in this video we're going to focus on gravitational potential energy, and in a later video we're going to talk about elastic potential energy. So what is the gravitational potential energy? The gravitational potential energy is defined as the potential energy associated with an object's weight and its height above the ground. In other words, this is the potential energy due to gravity. Using this definition, we can formulate an equation for the gravitational potential energy at a specific height above the ground. The gravitational potential energy is equal to the mass of an object times the acceleration due to gravity times the vertical position of the object. In the previous unit, we discussed that the work done on an object is equal to the force done on the object times its displacement times the cosine of the angle between the force vector and displacement vector. In this diagram, we want to find the work done on this box as it moves from a higher height to a lower height. We see that the force vector and displacement vector are in the same direction. So we can write that the work done on the object is equal to its force times its displacement. But let's expand on that equation. So we know that the force done on the box is the force of gravity. So we can write our force as Fg. And displacement of the box is going to be y1 minus y2, since it's moving from a higher height to a lower height. Well, we can expand this equation even more by rewriting our force of gravity as mg. And this will be multiplied by the difference of y1 minus y2. And if we distribute mg to each of the terms, we'll get mg y1 minus mg y2. And then we can further rewrite this as u1 minus u2, because these are the same variables we see in our gravitational potential energy formula. And we can further simplify this to as negative delta U. So this tells us that the work done by the gravitational potential energy is equal to the negative change in the potential energy. So in this problem, the work done on the box will be positive since the change in the potential is negative. Also, this equation will give us the correct work if the box is moving upward instead of downward. In that case, the work done will be negative since the change in potential energy is positive. So in later videos, we will expand on this unit and solve some practice problems so you have a better understanding on these topics. Thank you for watching this video and hope to see you next time.